Welcome everybody. Thanks for joining us for this call. The top of the agenda should say OAR Arctic All Hands Quarterly. That's the context for this meeting. And I know that we maybe failed to put that in a couple places, so apologies if people are feeling a little disoriented. We're going to spend the first part of the agenda trying to orient people towards why we're convening this call, and what the forward motion might be around OAR Arctic cross-line office communications and information sharing. But that's broadly the purpose of this call. We'd like to jump in with a short roll call, and maybe if people just follow the west to east listing that we've got down below, and just tell us who you are and where you're sitting. If you can see the screen that Emily's sharing, maybe I'll just shout out from there so we can do it in a more coordinated way, and then we'll jump into the full agenda. And can everybody also please mute themselves? If you're not muted, it's easy to pick up a lot of background sound.
I guess so.
And Gia, I think I might be hearing some background sound from your phone. I think I can actively mute people if I need to, but it's a little easier if you manage it from your end. So starting with CFAR, the Cooperative Institute at the University of Alaska Fairbanks. Do we have anybody on the line?
Hi, it says David Newman, but that's my husband. I don't know why he's showing up. It has nothing to do with CFAR. So
What does he know?
And I'm calling in from Fairbanks, Alaska.
Okay, thanks, Uma. Welcome. Anyone else from CFAR?
No.
Okay. And then PMEL.
Yeah, Overland and several others. Cal Morty.
Carol Ladd.
Hi, Cal. Hi, Carol. Anyone else from PMEL? All right, moving into Mountain Time, the Earth Systems Research Laboratory Physical Science Division.
Tennille Utah is now unmuted and here online.
Hi, Tennille. Thanks for using your web camera. Anyone else from PSD? Global Monitoring Division?
Hi, this is Diane Stinitsky. And Colm, are you on? Colm Sweeney?
I am on, yes.
Okay, excellent. I believe we're the only two people from GMD able to join today.
Okay, great. Thanks, Colm. Thanks, Diane. Anybody else from Esrael who might be on the line? Well, since I am in Mountain Time, I'll introduce myself. I'm Sandy Starkweather, and I sit at Esrael, though I'm a direct report to NOAA headquarters, OAR. Next, Glaryl, we heard Jia Wang. It sounds like you were on the phone. Anyone else from Glaryl? Okay, I think then we move into the East Coast and have Arctic Research Program.
Hi everybody, this is Emily Osborne. Thanks so much for being on the call today, Sandy, and I really appreciate it.
And others from CPO?
Hi, it's Ben D'Angelo.
Hi, Ben. Thanks for joining. Anyone else from CPO? OAP.
Yeah, hi, it's Libby and this guy.
Quite glad.
And sorry for the acronyms, that's the Ocean Acidification Program. We've got both our programs and labs on the line today. And then Ocean Exploration.
Hey, you've got Commander Bill Mowat here. I'm the Deputy Director.
Hi, Bill. Thanks for joining. Office of Weather and Air Quality.
Yes, this is John Opass joining.
Hi, John. Welcome. GFDL.
Hi, this is Mike Winton at GFDL.
Hi, Mike. Anyone else from GFDL?
That's it.
Okay. ARL, Air Research Laboratory.
Bruce Baker's here.
Hi, Bruce. Welcome.
Thanks.
And then AOML.
Hi, everybody. This is Dennis Volkov.
Hi, Dennis. Thanks for joining. Who did I miss?
This is Bianca Santos. I'm the new CNAS Fellow in International.
Hi, Bianca. I heard International. Thanks for joining us. Okay. So we're really happy to see so many people on the phone. We've got 26 people on the phone, and we want to make good use of everybody's time. So most of you should have gotten a request to send slides to Emily for our round the table update. And so anybody who did not see that request and wants to share something, just please enter a message in the chat. I know some people are going to just provide an update without slides. And we're going to do our when we get to the round the table, we're going to do the round the table in the same order that we did our roll call. But I will start by just providing a little bit of context on the sort of cross-NOAA structure for Arctic that was established during the last administration, but that lives on and meets on a regular basis at the leadership level. And as many of you are probably aware, less frequently through quarterly updates led by David Kennedy. Each NOAA line office has its own responsibilities towards this virtual NOAA Arctic research program. I'm showing you the website that was also created last year at arctic.noaa.gov. You may or may not be aware of it. It's a really nice skeleton of a website. It is always in want of more content. And so if anybody has ideas for pictures, stories, notes from the field that could constitute some content for the website that we could share, not just with each other in OAR, but across line offices and with the public, that would be quite valuable. So I'll just note that for those who maybe don't have the background, there's two kind of guiding documents that ride under a lot of this work that's represented at the website and by the efforts led by David Kennedy. One is that NOAA has an Arctic vision and strategy, and we have had one for quite some time. And there's also an action plan that is the implementation of that strategy. If you were on the last Arctic, NOAA-wide Arctic quarterly update, you might have heard that there's some discussion about updating that strategy. And so it's timely to take it off the shelf and look at it if you haven't looked at it in a while, and think about how your setting has maybe changed, how your priorities and directions have maybe changed, and how that might influence some ideas as we look across the whole agency. I'll ask Emily to go to the next slide. Again, just kind of trying to help people ground themselves in what we're talking about if this is sort of new language to you or you haven't thought about this structure in a little while. This is how that structure of NOAA's Arctic program is roughly envisioned in a very light Venn diagram. So the upper diagram shows the structure of the program itself. For planning and coordination, there's what's known as a leadership team with one usually SES level person from each line office and some of the supporting offices as well. And they're supported by two action team members. On the planning and coordination side, these groups meet monthly, and so they have pretty regular communication with one another at that level. On the implementation side is headquarters and the line offices itself, and so really the people on the phone here today are part of that implementation side of what we're talking about. And then, of course, thinking about things in a Venn diagram, there is, we know, a lot of activity at the interagency, international, and partnership level that intersects with what we do inside this kind of programmatic view across NOAA. And then additionally, there is a NOAA Alaska regional collaboration team that has a lot of interest in the Arctic, but not exclusively to the Arctic. Did I hear a question from the phone? Okay. And so with that, just to drill it in a little more finely, to find a resolution, I just made very quickly this very kind of light and high level org chart. I didn't even get all the way through filling it all in, but it's really just to give you the idea and understand why Jim and Emily and myself are convening this call. So for those of you who might have been familiar with Jeremy Mathis and his role as the director of NOAA's Arctic Research Program within Climate Program Office, he is on detail to the Hill right now. And so myself and Emily have backfilled and are taking on activities on his behalf while he's away. Which means for me that I'm the acting member of the leadership team that reports to David Kennedy on a monthly basis. Jim Overland has been a longstanding member of the action team, and Emily's just stepped into the second slot on the action team. And so that's why when you see taskers or requests for information, it used to be coming from Jim and I, and now you're going to be seeing it come from Jim and Emily. And then, as I mentioned, you are the all hands part of this. And so we're really happy that we had such good participation. We tried to do this call last year and we didn't have as systematic a means of reaching out to everybody. And we know we missed a lot of people. We did hope and continue to encourage you that the next time we do this, to reach back into your own groups and get people on the line if this is going to be useful to them. Otherwise, most of you on the line, we just considered key points of contact within your lab or your program for showing up for this conversation and providing some high-level information. So that is all I really wanted to share about sort of the context and setting for the call and what we expect to see coming out of this virtual structure within NOAA in the immediate time ahead. Jim or Emily, is there anything you want to add to this?
I think it's good. Maybe ask for any more questions.
Right. Yeah. So I'm sure there's probably some questions out there, and this would be a great time to field them if you have questions about this structure.
Hey, Sandy, it's Jen Pisa. I can add, just for everyone's awareness, I can add the leadership team for like OMAO, which is Commander G. Mark Miller. For international, it's Elizabeth McClanahan. For Ledge Affairs, we have the regional. We have Amy Holman. We also have General Counsel, which is Demian Spain, who's out in Alaska region. For Ledge Affairs, I'm sorry, we have Wendy Lewis.
Thanks, Jen. Yeah, I did not, I did not get time to research every name, and so I don't have a full org chart, but at some point it might be helpful to have a living version of this that people can access. And for those of you who don't know Jen Pisa, she works closely with David Kennedy and has done so for a long time, and can be a good person to get some quick answers out of if you have a cross NOAA Arctic question.
I guess one thing I can add was this is a real major improvement over 5 or 10 years ago where everything was ad hoc. We have Dave Kennedy and his group back there, and people have been pulled from different line agencies. So this has been sort of perking for 5 years, but we haven't really fully integrated all of you within OAR, and this is the first chance to really do that.
Hi, so this is Libby. I have a question. So the leadership team, can you just explain to me one more time the difference between the leadership team and the action team and what they're working on relatively, and then maybe an example or two of issues that the leadership team might be working on right now?
Yeah, so the leadership team is smaller, higher level, meets with the same frequency. The kinds of actions that they're working on right now would be, we need to start thinking about revising and updating the NOAA Arctic Vision and Strategy. How do we get started? You know, reach back into your lines and think about what's happening. Or very high-level activities that might be stemming from, you know, usually not new money for anybody, but things like, you know, a good example from international might be like the Year of Polar Prediction, and how we generate a little bit more understanding, more of a global view on what's happening. The leadership team tends to then task the action team if they need more information, or if they need, in particular, the action team can spend some time on taskers. They usually, the hope and intention is that you're not getting Arctic taskers from every which way, but that you, ideally, if there's something Arctic, you're going to be hearing about it from Jim and Emily. We know it doesn't always work that way. And then the action team also just kind of informs each other on, you know, upcoming major meetings, upcoming events. So there can just be a little bit of a better flow through of information.
So just one follow-up on that. Who then is Arctic? That interagency Arctic research?
Yeah, so that's a good question. If you look across this line right now, myself, Emily, and Candace Nachman are generally calling into IARPIC staff group. There's people from Weather Service who sometimes call in to at the staff level, but at the IARPIC collaboration team level, it's pretty pervasive. There's a lot of people engaging. And, you know, like Jim calls in regularly to the sea ice team. I'm a co-lead for the observing team. Emily's a co-lead for the environmental intelligence team. On the previous Venn diagram that, you know, is sort of indicated that there is meaningful overlap between the leadership and action side. But also some of that action comes from the implementation side, as we're going to hear from Ben D'Angelo later about his role engaging at the international level for Arctic. So it's not totally tidy, but it seems like there's good representation.
I might also bring up, you might want to look at that vision and strategy document. There some of the large issues that I think you all can buy into. One thing I've noticed on the structure is there's a fair amount of bureaucratic issues in response, and we're somewhat the interference for all of you. If there's something that really relates to you, we'll pass that on, but it's not something that all of you really need to know in some of the bureaucratic detail of various responses and what's happening.
Sandy, this is Ben. I have a question maybe for you or Jen. Is there someone in the administrator's office that David Kennedy in turn reports to on Arctic stuff?
So, so he doesn't report to officially, there was a change last year to move the Arctic leadership into NOS officially. So officially he reports to Russell Callender in NOS. The contract, and that was for a host of reasons. But the people that we speak to most often is Kevin Wheeler and for policy issues, and straight away to Admiral Gallaudet. He's been an incredible champion for the work that we're doing.
Thanks.
Any final questions on the organizational piece? And also, I'm recording this meeting, and we can push around the full slide deck when we're done. I'll take Jen's inputs and finish filling out this org chart just so people have a good go-to reference. And Emily likewise has generated a really nice kind of cross OAR labs and programs point of contact list for Arctic that people can have at their disposal. Okay, so rolling through the slides, this is your turn now. For those of you who sent slides in, as I said, we'll just go in the order that Emily's already collated them in the order that we had listed with our west to east rollout. And then if people miss their opportunity to get their slides in, again, just put your name in the chat and we'll get you ready for a presentation at the end. Because we got a lot of people on the line, you know, we did the math, and if you go for longer than 5 minutes, then we're going to run out of time. So if it's helpful, I can set a timer and let people know.
Thanks, Sandy. Okay, so we're going to jump in, and Uma, you are up first with CIFAR.
Great, I will. So kind of the key point I want to talk about here is I'm going to highlight a few current ongoing CIFAR funded activities through NOAA that we can build upon and think about how CIFAR goes forward. Because as probably most of you know, CIFAR's point needs to be recompeted, but before the recompete, we need to really think about what kind of structure would be ideal to get advanced Arctic, Alaska and Arctic science, and what kind of structure does CIFAR need? So that's kind of been at the top of our concerns. And so CIFAR currently has 3 themes, and I'm just giving individual examples from the different activities that go under each of these themes. So one of them that I want to highlight is this autonomous observations of ocean acidification. And there's been really, good work, really nice, new science that's shown how well, for example, sail drones have worked. But kind of the next step that there have been ongoing conversations with PMEL, how do we take those sail drones and then take them to long-term observing? Can we find local technicians, for example, in Kotzebue, who would then take care of this, so those wouldn't have to be transported? So again, kind of I think the strength of Alaska is taking things from the science realm all the way to the operations. And that's where I see that CIFAR can rework itself to serve NOAA better. As a second example is, UAS technology, I think, is going to be really important for the Arctic. And it's been shown to do well for stellar sea lion surveys, other mammal surveys, and the new developments at the Aliktok Point facility that University of Alaska is developing, I think can be a really good way to test and to figure out how to take these technologies to something more practical. I wanted to also finally just highlight the third theme is climate change and variability, where we can download data fairly quickly in Alaska, but efficiently at polar orbiting data. But then it really takes this partnership with many different parts of NOAA in order to create products that are then available for the Weather Service. So this is an example that GINA, which is our Geographical Information Network in Alaska, is currently doing. And then the second thing I want to highlight here is something that's not directly related to NOAA, but it's a current ongoing activity that I think is a real example of what kinds of things CFAR can be contributing to. And ISEX is a field experiment by the Navy, and the role that scientists at University of Alaska and partners are playing is putting together the ice, the atmosphere, and the full information to provide outlooks on the 2-week and longer time scale. So it's different than what Nick is producing. It's different than what the Weather Service is producing. And as part of this activity, you know, getting all of us together in the room, it's really made us think about how to transition research findings and new methods to something operational. An example is we've been playing with the analog forecast that's been funded through NOAA, the RISA, as well as through competitive fundings. Also, by having the scientists that are part of the UAF team participate in the domain awareness flights, it becomes very clear where those research pieces are. And again, I guess Alaska has the advantage that it's small and makes these collaborations easy. And it's also a disadvantage in that there's fewer people. And kind of the third part of this is where using observations from Israel, from Amy Solomon's group, and we can help in terms of linking what's, you know, new technologies. For example, there's a buoy and there's some other data that's being collected as part of this that can then be, you know, brought to OPC for model validation, as well as to Amy's group at Israel. So again, sorry, I'm trying to make my 5 minutes here, so I'm going a little too fast. But again, it's this idea of working, you know, partnerships that help us take things from, you know, research to operations. And my next slide is, as we're thinking about this CFAR recompete, our long title is Implement Sustained Observations of a Rapidly Changing Arctic and Alaska Environments to Inform Response. But really the short description is Arctic Ready Change. And these are mapping different ideas that were put forward by white papers from University of Alaska scientists, and I mapped them onto line offices, and it's taking it from observations to response. And I won't, kind of the key thing is how do we connect all these pieces? And my next slide, which is just an arrow that will connect these different pieces. And right now we're working on a document to give to Craig McLean to kind of propose how this can be done and how we can fit in with how we can fit together different agencies, different partners, as well as local stakeholders. Thank you.
Thank you, Uma. All right, so we've got Jim next.
Okay, PMEL has a wide interest in the Arctic. The biggest one is a large ecosystem field research program, a lot of it combined with NIMPs, and there's a lot of new technologies that's involved with that. We also look at model assessment and weather issues. One of our main outputs is broad communication to a lot of different groups, from the public to managers and so forth. And we lead the Arctic report card and are involved with several Arctic assessments. Next slide. This shows the extent of our field program. The stars are moorings and the red dots are fishery survey places. We've got 7 years of time series on a lot of these, so we're starting to be able to sort out interannual variability. And the main thing here is to have a baseline on the environment before there's a lot of increased heavy uses in the Alaskan Arctic. Next slide. Hit it again. Uh, some of the technology are sail drones, the independent platforms that are loaded with instrumentation, and they went from the Aleutians up to the Ice Edge last winter. Another one is a glider that has biophysical measurements on it, and it gives high resolution both in the horizontal and vertical. Last year, they noticed that a lot of primary production was occurring in small eddy features that you couldn't see with normal shipboard sampling. So that's really done a new paradigm. Also, we've got minimum ice extent last fall, and almost no ice in the Bering Sea right now. So we're way out of any previous experience in the Arctic. So the issue is to have high intensity field programs every year. The next slide. Another piece of technology is an airdroppable sensor that profiles ocean temperature and reports that in real time. Here's a record from fall of 2016, and the idea here is to have initial conditions to be able to predict both short-term forecasts and the delay in timing of fall freeze up. And so we're working with NWS and Israel and modeling and so on. I think even though we have some more modeling going on, and unless we have an improved observational system for the Alaskan waters, I think we're going to be real in trouble in case there's shipping issues, oil spills, that sort of thing, unless we've got a better observation basis for the forecast. Next slide. PMEL has been involved internationally on our chemistry. One of the big conclusions is sulfates have been going down as measured at Barrow and other places, and sulfate is a cooling forcer. So the fact that sulfate is going down actually ends up with contributing to the amplification of warming. Next slide. And finally, I'll just bring up some recent results on whether changes in the Arctic impact mid-latitude weather. And we can look at what happened last December with the real late delay in freeze up and other things. We had a real major warm anomalies over Alaska shown on the left-hand side. Warm air is less dense, so it increases the height of geopotential height pressure surfaces, which then is the link then to winds. And so that those increased temperatures help.
I just want to give you we're a little over time.
In a wavy jet stream. Okay, and so what was going on Alaska helped prolong the cold East Coast temperatures. Okay.
All right, thanks, Jim.
Great, thanks. We might have time for questions as well.
questions? Or
I mean, at the end.
Okay. All right, so we're moving on to Ezreal PSD with Tennille.
Okay. Hi, everybody. I originally sent Emily a deck of slides that was too big to actually even transmit. So I think I only have my first 3 slides here, so I'll be able to keep this short and sweet. However, I'm hoping that for the group that we can post my full deck, because what I had after my first 3 slides is an illustrative slide for each of the bullets that I'm going to discuss. And a lot of them have web links about what we're doing, so I think they're pretty informative. So at here at PSD, we have 8 teams, and I'm lead of what we call the Polar Observations and Processes team. We internally call ourselves the Popsicles, and there's a link there to our website. And this mosaic here is supposed to sort of give you some idea of the fact that we spend a lot of time in the field. We are primarily observationalists, and we are working with a number of stations around the Arctic, and we are working with a number of large field programs like Mosaic, as well as developing a coupled system model. Next slide. So here again, for each of these bullets, I have a separate slide that you can view separately. I would say that our POP science specialties are Arctic surface energy budgets. I saw Bruce Baker online, I think, and we have just recently had an ARL PSD summit, and we are talking about trying to harmonize how we do these critical surface energy budget and boundary layer characterizations. We have a marked specialty here in Arctic clouds, microphysics, and climatological quantities. We have got coupled system modeling going on with something we call the RAS and Ezreal model, which has been designed mostly for sea ice forecasting, but is a fully coupled atmosphere, terrestrial, ocean ice model. We are working with Arctic aerosols, trace gases, and pollution. Regional processes and transports, and I'm going to kind of well, I'm going to come back to that one in just a minute and use my 5 minutes to soapbox a little bit. We are developing new observation technologies that are specific for the Arctic for atmospheric parameters, and sort of a new thing is this creation of what I consider to be canonical data sets from these long-term observations and campaign measurements that we support. So that's kind of our specialties, and some of the things that we actually have going on right now is we have this International Arctic Systems for Observing the Atmosphere. It's www.iosoa.org, and that kind of sweeps under this gigantic umbrella all the measurements that we are doing at Tixie, Greenland Summit Station, Eureka and Alert in Canada, and the 2 locations in Alaska, Elliptic Point and Barrow, which I shouldn't have put Barrow. I should have put Utqiagvik, which is the new name for Barrow. We take that observational model, and we're working very closely to associate that with this coupled forecast model that we're developing. Currently, we have a big de-ice experiment going on in Barrow, where we're trying to figure out the best way to make broadband radiometric measurements. I think most of you know the acronym MOSAIC, which is going to be a large year-long project that's going to be in the Arctic Ocean starting in a couple of years. And Matt Shoup from my group has been one of the primary leaders developing that program. And then Janet Enchereri and Heistabor are involved with a lot of interagency UAS Arctic activities and planning. So I'm going to pause here really quickly, and I'm going to come back to my soapbox. We can go to the next slide while I soapbox. And my soapbox is I think that right now, the year of polar prediction is something that is a major activity that NOAA research could be grouping around. We do have 2 or 3 people on YOP, either teams. We have 1 person who's on the YOP steering committee. But I feel like NOAA's kind of missing an opportunity now for a very well thought out and well planned international program that is specifically for improving forecasting and predictability for the Arctic, not only for the Arctic, for linkages to the mid-latitudes. I think we were responding very, very well from the observational parts of NOAA to support the yacht verification teams, but I think the modeling teams right now are seriously underrepresented. And this slide, and then I'll pause again on this slide, and we kind of put together this poster, and we're kind of trying to wrap up everything we do here, showing that we've got these observatories around the Arctic, and then those two panels on the side should give you some idea of the kind of processes that we work with and that we are specialists with. And then I've got in the middle of the ocean sitting there is the mosaic ship that will get frozen in. I would like to mention that there is a satellite program being developed by IAS called T-Mosaic, where we are going to try to expand the scope and the impact of mosaic by coordinating observations at the surrounding observatories. So that gets to be a much larger experiment. And I'll stop there, and we can come back if there's any time.
And great. Just to spell out the acronym, IASC is the International Arctic Science Committee.
Thank you, Tennille. Okay, we're going to move on to Esrol GMD with Diane.
Hi, everybody. This is Diane Stanitsky. Just wanted to talk. I have 3 slides here that show what the Global Monitoring Division does. Basically, we're in the business of long-term or sustained observations, and we like to call it that we're taking the pulse of the planet. We have a series of groups, science groups, that focus on different aspects of measurements. And one place where we host many different unique measurements, over 120 of them, is in Utqiagvik at the Barrow Atmospheric Baseline Observatory. We have supported this observatory and collected data along with many, many partners for almost 45 years at this site. The site's at sea level, northernmost point in the U.S., and we have 2 full-time technicians there measuring many different things, including aerosols and different gases for the carbon cycle, solar radiation, and we support many different cooperative research projects. A number of them are listed in the lower right corner of the slide, but I wanted to mention that we're really trying to make this, and have made this over time with the support of many others, a cross-cutting super site. And there is room to host additional projects, but we're challenged right now with resources for sustaining all of the measurements that are of interest for this region within the Arctic. But it really is what we have our greatest interest in doing, is supporting long-term measurements to see how such a rapidly changing part of our environment is changing. And so we also support some studies that focus on indicators of changing climate. Let's go on to the next slide. In addition to hosting long-term measurements at Barrow specifically, we, as Tennille said, we're also hosting a 1-year project called De-ice, and that's the de-icing comparison experiment. And the purpose of it is to test different strategies that are developed by different research institutes and industry to prevent radiometer icing. So you can see the picture in the top of the slide that shows 26 different devices that measure shortwave radiation. And we're looking at the best way to make broadband radiometric measurements that are most accurate. So this is an experiment that's primarily, it's a collaboration between the Physical Sciences Division and the Global Monitoring Division. And Chuck Long in GMD and Chris Cox and Sarah Morris in PSD have been focusing on this project. The link is there if anyone's interested in some of the results over time, but it's a collaboration with the Baseline Surface Radiation Network and specifically the Cold Cloud Issues Working Group, and then also with industry partners who have a whole series different designs and ventilation techniques to try to mitigate ice on the surface of the radiometers to get the most accurate measurements possible in an environment where riming and snow accumulation is, of course, a challenge. And you can see the slide, the picture in the bottom right corner, which is what the environment looks like for much of the winter period. So that's one shorter term project. The last slide focuses on a field campaign, and I'm going to turn it over to Colm just to talk briefly about his project called Arctic Cap, taking different atmospheric measurements using aircraft. Colm?
Yeah, this is part of about a 10-year bunch of experiments where we've been using aircraft, which include the Arctic Domain Awareness flights from Kodiak Island that the Coast Guard runs. But this is funded by NASA, and this is a 10-year-long project that NASA's embarked on. And our part is to measure the atmosphere CO2, methane, CO profiles. And so this campaign started last April and ended just recently in November, and ended up being about 50 to 56 different flights, 6 different campaigns over that 6-month period. And you can see the results right in front of you, but lots of profiling and lots of coverage into Canada as well as the Arctic. So really extending sort of our observational base from Alaska only into the Canadian Mackenzie River Delta and that kind of area.
All right, thank you so much, GMD. So we are going to move on to Glarel. So Gia. Do we still have Gia on the line? Gia, are you on mute?
Hi.
There we go. We can hear you now.
Yeah, I'm sorry. I was asked only submit 2 slides. That's fine. And 2 slides here. The first goal, we investigate Arctic climate dynamic modes. Number 1 is Arctic oscillation, but the second one is Arctic dipole anomaly, we call DA. That is the major forcing to accelerate Arctic summer sea ice decline. So if we look at the left picture, we can see the trend of the sea ice decrease before 1995 is one rate. The other rate is accelerate after that. So if we continue this trend, that will be, we will soon have an ice-free summer Arctic in 2035 or 2040, and sooner or later, that will have a significant impact for the commercial shipping. So we have conducted the relationship of Arctic dipole anomaly with the opening and closing of the Northeast Passage and Northern Sea Lough and Northern West Passage. So that is have a significant economic impact because it will reduce at least 30% of the I think the cost for the shipping from the Arctic to the Europe and to New York and to through the Arctic sea loughs. So this is our climate investigation. And second slide, please. Yeah, we have long been developing couple ice ocean ecosystem model in the Bering, Chukchi, and East Siberian, and now in Arctic Sea. So we developed in the Bering Sea and Bering Chukchi Sea model, we use the CIOM, that is a couple ice ocean model we developed over the year, and to simulate the circulation and ice cover, and also the phytoplankton and zooplankton in the region. So we found this model can represent or reproduce the temperature-dependent phytoplankton bloom, and also we found ice cover have significant impact on the ecosystem, because our model include the ice algae model as well. And this model we also apply to the upper panel in the Bering Sea, that is a structural grade. And we also apply this structural grade model to the Pan-Arctic, and I don't show here, and covering the entire Arctic, Pan-Arctic. And we have run the model for 30, 40 years so far. And so the entire Arctic is have been covered. And so that will open up the opportunity to couple our ice, ocean, and ecosystem model in the Arctic. Then recently we developed a super high, we call Arctic FVCOM plus ice, with FVCOM in finite volume, coastal ocean model, with ice model, with unstructured variable triangular grade. So we can see the resolution we have variables vary from 2 to 10 kilometers, and covering the entire Pan-Arctic, including the Canadian archipelago. The purpose is we want to investigate not only the ice-ocean coupling system, and in the near future, or we are able right now, I believe we will couple the ecosystem into this high resolution model as well. And we also can use this model to investigate the opening and closing of the Arctic sea louse, because our model is fine, the resolution fine enough, including resolving Canadian archipelago. So the northwestern passage can be resolved. And right bottom right showed we simulate the ice cover. This is concentration with surface velocity. So so in short, GROW we focus on climate change, climate more dynamics, and also we focus on develop our regional model. The model right now we can simulate the landfast ice. We are going to include the wave ice interaction, particularly in the Pacific Arctic. After the I think because the opening up in the Pacific Arctic, wave have become a significant phenomenon recently in last 2 decades. And so that is a potential. We would like to contribute our expertise in GROW, and then collaborate with the PI and other scientists to work on the model improvement and model, I think particularly like the ice wave interaction module, and ice and tides interaction. So all this we will work on the, I think, technical area, and then apply to the regional Arctic Sea and also the entire Arctic. Thank you very much.
Thank you for that update, Gia. So next is the Arctic Research Program. So I'm going to give a quick rundown. So the Arctic program is continuing to support our 5 lines of effort. So I'm going to go over the first 4, and then Sandy's going to take on the last. Continue supporting the Distributed Biological Observatory, which I'm sure many of you are familiar with as it's been a project that NOAA has supported for a long time. This is also done in partnership with the Pacific Arctic Group, so it has a great international component. So last year in 2017, we supported a distributed biological observatory, Northern Chukchi Sea integrated study, with the aim of observing the distributed biological regions 1 through 5. So we spanned the Northern Bering through the Chukchi Sea, collecting water samples, observing changes in the physics that were going on, benthic sediment samples where biomass was observed, as well as marine mammal and seabird observations all happening at the same time. So really the essence of DBO is linking whales to physics, so working the entire ecosystem and observing this long term to see how the Pacific Arctic region is responding to changes in climate. And so next year, or this year, excuse me, in 2018, again, we're going to go out on the Coast Guard Cutter Healy. So we've got a good partnership with the Coast Guard to conduct our DBO missions. We're going to be there in August. We have a total of 19 days at sea. And this year, the cruise is unique. It's going to be conducted in partnership with PMEL and supporting the Eco-Foci project. So we're going to be recovering a number of moorings. I think it's 22 moorings. And we're going to collect physical samples at anywhere from 80 to 100 sites, depending on how quickly we're able to turn around our moorings. Last year, we had an extremely successful mission. We had 160 sampling locations that we were able to collect samples throughout the region. So we support a number of PIs to conduct science aboard the Healy, and one of our PIs focuses on ocean acidification research. And in conjunction with the DBO mission last year, as well as this year, we are going to be rendezvousing with sail drones that are going to be conducting their mission again in the Pacific Arctic region and the DBO regions. So last year we had 2 sail drones, which Jim gave an update about earlier, and this year again, I think we're anticipating another 2 going up, and the Healy, the DBO Eco-Foci crews will be meeting with the sail drones and conducting some calibrations. So line of effort 2 is supporting unmanned drone and glider surveys in the Arctic region. So line of effort 3 is continuing to support the ISOA project, which Tennille just gave us an update on, which is really critical long-term observations of atmospheric changes, and is a nice partnership, an international partnership as well. And then line of effort 4 is to support diagnostic reports as well as model support of changes in climate, sea ice, and ecosystem response. And so one of the diagnostic reports that we're really proud of is the Arctic Report Card, and continuing to support that this year. We put out the 12th Arctic Report Card, had a really successful rollout at the AGU fall meeting, got a really positive amount of press. So I was actually just meeting with our website team today, and they indicated to me that the analytics showed that on the day the report card was released, we had over 5,000 visits to the Arctic program website. So really excited that we seem to be getting out some good science to the community. And with that, I'll turn it over to Sandy, and she can cover our 5th line of effort.
Thanks, Emily. So the 5th line of effort in the program is a relatively new line of effort that was started last year, which is the U.S. Arctic Observing Network, which is a sort of cross-cutting wrapper activity, the broad mission of which is to develop systematic approaches to maximize the societal benefits of Arctic observing across agencies. So that mouthful really means that NOAA is supporting the U.S. AON office, of which I'm the executive director, to increase our sort of the accessibility to our international partners of U.S. actions through trying to create greater coherence and a better kind of comprehensive look at what we're doing. We're moving into looking at what would be a framework approach. We've been reviewing the framework for ocean observing, finding that to be a really useful model for how we might try to encourage and charge the U.S. research community to move forward on Arctic observing. But we're also have been over the last year spinning up what we call more task-based work. So if the framework is are the links that help draw the network together into greater coherence and show overlapping opportunities, the tasks are really the nodes where we're developing some new products and services out of observations we're already making. So some examples of USAON tasks that have gotten out of the gates already that I've listed below. The first and the one we've made the most progress on is mobilizing better observations in support of sea ice forecasting. We've been working closely with some of the folks you heard about on the phone earlier, like Janet and Trary at Esrael with that model, some of the modeling folks, I should say, but also trying to harvest as many of the observational assets as we've got available into better multi-sensor data products. EPA has, so this is an interagency effort that NOAA has put a lot of resources in. So you see a lot of other agencies coming in and wanting to lead on ideas of their own. EPA is really interested in wildland fire. And then we have some emerging tasks coming up under ISOA and DBO both. So in the year ahead, I anticipate you're going to be hearing a lot from me and others about launching into a framework process. Stay tuned for that. And I'm always open to hear ideas that people might have on actionable tasks.
Thank you, Sandy. All right, so we're going to move on to CPO. So Ben D'Angelo is on the line.
Hi, everyone. A lot of folks on this call don't know me yet, so I thought I'd just introduce myself a little bit. So I've been here at NOAA only for about 9 months or so I'm still finding my way around the agency. So forums like this are helpful for me to learn what's happening across the agency. I spent many years at EPA, about 18, and then for the last year and a half before coming to NOAA, I was at had a joint detail with the White House OSTP office and was the deputy director of the U.S. Global Change Research Program. So I'm the new, relatively new deputy here at the Climate Program office. And one of the things I wanted to highlight for folks is that I also recently took on the role to be the new head of delegation for the AMAP working group. I assume most of you are familiar with this. This is the Arctic Monitoring and Assessment Program. It is one of at least six working groups under the Arctic Council. So its membership reflects the same membership of the Arctic Council, the 8 countries that have at least some territory in the Arctic: US, Canada, Scandinavian countries, Russia, and it also has the indigenous groups represented, named the permanent participants. I just recently attended my very first heads of delegation meeting of AMAP. It's as I already knew, it seems to be a fairly collegial and supportive group. So I do think it's a group where you can actually get things done. Russia was well behaved in the meetings. There was nothing that was really too difficult getting agreement on. There's a lot of activity happening under AMAP. My impression was maybe they're doing a little too much. There's quite a lot going on, and they're doing a lot of things that touch on what not only the Climate Program Office is doing, but it really touches on a lot of equities across OAR, across NOAA, and really across the agencies of the US government. Just highlight a few things. AMAP is very close to developing its new strategic plan. This is really only like a 3 or 4 page document. For the remainder of this year, it's going to go through the other hoops of the Arctic Council to get approval. That means ultimately getting approval from the senior Arctic officials. It has work going on, follow-on work on short-lived climate forcers, on black carbon and methane. This is an area of work where I personally have a lot of history with the Arctic Council. So they're building off previous assessments. Jim Overland is involved in some of the ongoing work on projections, finding contributions to IPCC, and in particular, kind of teasing out the Arctic storylines from the CMEP6 database. That's the new ensemble of projections that will feed into the next major IPCC assessment. There's ongoing work on Arctic ocean acidification, building off of AMAP's previous assessment. They are hoping to get as far as they can by this October for the Arctic Biodiversity Congress. Libby Jewett was able to comment on the case studies feeding into this. And Libby, if you're still listening, I owe you, actually Emily and I owe you a follow-up on that. And AMAP has been doing a lot of work on regional adaptation studies, adaptation to climate change. And they want to mine a lot of that work for lessons learned. There is a short 2 or 3 page summary of all of these activities in AMAP that I've circulated to some of you on this call, but maybe Sandy, I think you received that from me. You could, fine by me if you want to circulate that to this group. I also just wanted to flag for people's awareness 2 other kind of high-level meetings that are going to happen. One closely related to the Arctic Council, one kind of more loosely related to the Arctic Council. One is an environment ministers meeting that's going to happen in October, being planned, hosted by Finland, and they want this to immediately follow the Arctic Biodiversity Congress. My understanding is that the themes and the topics are still under development, so I think there's going to be opportunities for us to provide input, working in close collaboration with the State Department. Finland identified these 3 themes: biodiversity, conservation, pollution prevention, and climate change. That doesn't make
And I have to play my role as the timekeeper.
Okay. All right. Arctic Science Ministerial, I don't have a lot to say, but there's the website there that sketches it out. And I just want to highlight on the next slide 2 competitive research areas supported by CPO. One under the MAP program, Dan Barry's a contact. We recently received a bunch of Arctic-related proposals in response to competition. So Dan and others are going through these proposals now. And under our CVP program, where Sandy Lucas is the point, there's information on the next couple slides of a bunch of projects that we funded in FY15, and they're going to be finishing this year. So those slides are there for people's edification. Thanks.
Okay. All right. Moving
Thanks.
on.
I'll just, in general timekeeping, we've got about 20 minutes left, and it looks like we have about 10 slides left. So that's kind of our parameters.
All right. So quickly moving forward, we've got Dwight on the line for OAP.
Sure.
He just has 1 slide.
Literally 1 slide, so we'll be pretty brief about this. So for those of you who don't know, NOAA's Ocean Acidification Program is directed actually by congressional decree to do several things, but primarily it's to understand the implications of ocean acidification to society, to U.S. marine resources. So we are charged with establishing an ocean acidification observing network and understanding species sensitivities to those chemical changes and understanding societal relevance of any of those impacts. So we've been very interested in the Arctic, we'll say that, scientifically. We've recently learned that it's one of the most quickly acidifying waters on the planet as a consequence of some shifts in oceanography that are actually driving increases in DIC loading into the system. So that it is of concern to us, but to date, much of our program investments have actually been south of the Arctic Circle. We have some limited investment. Certainly the Gulf of Alaska is an area of past and continued interest to us. We fund not only a number of experimental studies at the Alaska Fisheries Science Center to understand species sensitivity to ocean acidification in the Gulf of Alaska, as well as modeling studies. We also have resources dedicated to observing the chemical changes in the Gulf of Alaska. Specifically, we have a number of fixed mooring assets. I think the CFAR presentation referred to some of those that monitor ocean acidification dynamics. Those actually provide both at the surface and in the subsurface, which is relatively unique for our network. We also have a dedicated Gulf of Alaska survey cruise, which occurs repeatedly every 3 years. 4 years, sorry.
4 years.
4 years. And so the next one's queued up for next year, 2019. So we'd be looking for any leverage in any way we might be able to facilitate any of the Arctic needs. We do have actually one asset that's physically located north of the Arctic Circle, and that's actually off of Iceland.
Yeah.
So other than that, I would say the other key thing we provide for is a considerable investment in data management as it pertains to ocean carbonate chemistry. And so we have set up both a means of inputting all of our community's carbonate chemistry data, including any of the stuff that's being advanced out of PMEL or elsewhere on carbonate chemistry within the Arctic, can be ported through our data system that we've set up at NCEI. And we've also facilitated the transfer of CDAC, which was the International Global Carbon Data Set that the community used from the Department of Energy into NOAA, into NCEI. So that's something else we've done. What else did I miss? Anything?
Boom, done.
Boom, that's it.
Great, thank you so much, Dwight and Libby. So we're gonna move on to our next update, which is with OAC, and we have John Opatz on the phone. My computer is freezing. Okay, there we go. John, are you still on the line?
Yes, I am.
Great, thanks so much.
Yeah, no problem. So this hopefully will be a little short just because this is the first time that OAC has actually dipped its big toe into the Arctic arena via the JTTI, which is the Joint Technology Transfer Initiative funding call. So I figured I'd just give a really quick overview of what JTTI is and explain how we got to the sea ice forecasting priority, which is new for the FY18 call. So JTTI began in 2016, currently divided into 2 calls, both an internal, which is a Fed only, usually funded through 3 years, and a external, which is usually 1 2-year projects, and that's through educational institutions and the larger weather enterprise. And they're allowed to submit whatever they want, matching whatever priorities. In the past, we've had as few as 2 priorities, and this year we currently have 4 with sub-priorities under each of those major priorities. Current funding is $2 million, which we saw quite a splash since last year, as I'm sure all organizations feel. But we still are able, with that money, to fund at least 6 to 11 projects. This year, I think we're up to 7 to 12. We're making the money stretch a little bit further along the projects. As I said, they span usually 1 to 2 years for the external, and internal they go for 3 years. And we try to focus on the RL or readiness levels of 5 to 8. These are the same kind of things that NASA does. Instead of technology readiness levels, we just use RLs, which is anywhere from 5, which is the validation in a relevant environment, which is usually in our in-house testing, all the way up through a demonstration or a mission qualified demonstration. This year, we've actually included the readiness level of 4, which is a laboratory environment. So that's trying to promote those little guys who don't quite have their research all the way up to NOAA level, that they're still working on it in their own lab environment. We're hoping to kind of promote that research to operations focus and get a little bit more of the research and a little bit less of the closer operations guys. So on the next slide, we can actually see how the sea ice forecasting priority got in there. It's labeled as improving daily to sub-seasonal scale Arctic sea ice forecasting. And broken down into two different priorities in the FFO this year. One of those is the actual development, testing, and evaluation of the scale, the subseasonal or daily scale Arctic sea ice forecasting. And the other one is through the evaluation and reanalysis of the data sets that currently exist. And the hope is that we get enough interest in this stuff so that we can close the gap that was identified by David DeWitt in CPC as one that needs serious addressment. This year we did get the largest volume of LOIs or letters of intent that we've ever received. Usually we receive anywhere between 20 to 25. This year we had 83. That was overall for the JTTI. Unfortunately, only 7% of those, or about 6 LOIs, were addressing the Arctic sea ice priority. So in the future going forward, we really like this kind of organization to hopefully spread the news about if JTI is still here, as long as the funding still exists, and hopefully get some more LOIs and some full proposals funded. And hopefully, as time goes on, I can report back that some of these projects have received full funding. That's it from OAC.
Great, thanks so much, John, for that update. And we're going to move on to GFDL with Michael Winton, and Michael has 3 slides, so he's going to talk very quickly.
Okay. Hi, everybody. This is Mike Winton at GFDL. So I have 3 slides, 3 different projects at GFDL. I can't see them. I wasn't able to get Zoom to working, but hopefully you're looking at one about CM4 development. So CM4 and ESM4, which is the Earth System counterpart, are our models for doing the CMIP6 model intercomparison exercise that Ben mentioned earlier. And so CM4 has been under development for about 4 years, and it's come to a conclusion, and now it's actually running the CMIP6 experiments. CM4 we think is a big improvement on our previous models. It's a higher resolution model. It has a 1 degree atmosphere, 1/4 degree ocean, comprehensive representation of the physical climate system, including aerosols, some simple ocean biogeochemistry, dynamic vegetation, that sort of thing. And it's producing a very good simulation. So the panels I'm showing you here are the simulation of the Arctic sea ice decline in March and September compared to observations. And as you can see, it's comparing very well, but more broadly as a global model, we think it's a big improvement over our previous models. It does a very good job of simulating the present day climatology and variability such as ENSO variability and teleconnections, AMO, PDO, that sort of thing. Looking more to the Arctic piece of the model, we've upgraded the sea ice from CIS to CIS2. CIS2 is a C-grid model for compatibility with MOM6, which is our new ocean component, been adopted by NCAR and NCEP and other places. The thermodynamics in CIS2 is now quite similar to CICE4, and that's really our pathway for further development of CIS2. Going forward from CM4, we plan to base a lot of our further developments on the so-called ICE-PAC, Community Ice Physics Package, which is, you can think of it as just being the sea ice physics part of the CICE model, which has been broken out and being developed in a community fashion. So next slide, please. The next slide talks about our prediction and predictability efforts here at GFDL. These use our forecast model FLOR, and which was really not developed for Arctic purposes, but when we, I think it was about 5 years ago, we looked to see if the model actually had skill predicting or hindcasting Arctic sea ice, Pan-Arctic sea ice extent, and we found that it did. And that project was initially led by Rim Masadik, and she left GFDL, but now it's being led by Mitch Bushuk. And he's done further analysis of the model, now looking at, in a recent GRL paper, at the regional skill. So in the 12, or I guess 13, 14, 15 regions, 14 regions, looking at whether the model has skill in these regions. And so an example of that is shown in the in the lower right panel where you see the target month for the forecast and lead time on the vertical axis, showing the skill we have in the Barents Sea in this case. He's got a paper that's in review right now at Climate Dynamics, which is looking at the perfect model skill. So we can now, for the same model, so now we can look and see where we have opportunities for improvement, and that's for the Barents Sea. The Barents Sea that's shown in the top right panel. You can see that there's a lot of room for improvement. So this is a nice study that kind of shows us where we should look to make improvements to the model. We think, based on our analysis, that the wintertime skill comes from the simulation of ocean temperatures. The summertime skill comes from representation of sea ice thickness anomalies. We're not actually assimilating at this point any sea ice data. We do have long-lived thickness anomalies that give us predictability, but those are just generated outside of the sea ice and the rest of the climate system. The next step for this project is going to be to try to actually do a simulation of sea ice thickness and concentration to try to improve the skill of the model. And we're looking forward to incorporating our improvements into the successor to the floor model, which will be based on CM4. It's CM4 with a 1 degree ocean instead of a 1/4 degree ocean for efficiency. This effort called SPEAR at GFDL. Okay, so the final slide is on a project led by Rong Zhang at GFDL with her collaborators, looking at the relationship between sea ice anomalies in the Arctic and ocean variability on the multi-decadal timescales. And so the sort of motivating question here is, why is simulated Arctic ice decline often less than the observed? In our model, you saw that it was in pretty good agreement with the observed, but I should say that it gets that with a global temperature trend, which is too large over that same period. So she's looking for the potential for low frequency natural variability in ocean circulation, mainly in the Atlantic related to the AMOC overturning, but also in the Pacific with heat transport through the Bering Strait to contribute to sea ice low frequency sea ice variations in the Arctic, and finding that, and you see in the regression in the upper right panel. And a recent study looked at the ability of the sort of discrepancies in the CMIP5 models, showing that in the in the Jin Seas and in the Barents Seas, the model average shown at lower right has a decline in sea ice, but it's less than the observed. And her thinking is that natural variability could be contributing some of that difference. And if that's the case, well, that's important, because the natural variability component of the decline, of course, won't persist into the future. So it influences the forecast that we would make for the future. So that's just a little summary of 3 projects that we have ongoing in the Arctic at GFDL.
Thank you so much, Michael. And we're going to move on to ARL with Bruce Baker.
Okay, bring up, oh, there we go. So we're involved with what's called the U.S. Climate Reference Network. It's a set of network of in situ stations. We've got 122 in the U.S., but we're also building out in Alaska. We've got 21 in the ground. We plan on putting 1 more in this year. And we've got 7 stations left to install between 2019 and 2022. These stations measure global radiation, temperature, relative humidity, surface temperature, and most of these have been in the ground we started about 2006, 2007, but it's a network that we've got. The blue ones are the ones that we have installed. The green ones that's where we're going to install, and the yellow ones are the ones we have left to install. So it's a network that we're having a distribution across Alaska. We're co-located with GMD and Barrow, and we're just now starting to get sufficient data to look at some climate change, some trends that we're seeing. So next slide, please. This is just a visual. These are the dates where we've got at least 8 to 12 years of air temperature data, for example. And we do see in this very short period of time that we're seeing some pretty dramatic increases in the temperature over this very short period of time. These are all along the coast of Alaska. The interiors, places like Fairbanks and aren't showing the dramatic increase in the trend as much as on the coast itself. Next slide. So as Tennille alluded to, we had a summit with Esrel. And one of the things that surfaced out of that was really collaborating with PSD's polar processes and observations to look at how we can sort of standardize some of the flux measurements. There's all kinds of ways to calculate fluxes, but so you can end up with really, different numbers. So we really want to try to come up with a way to standardize not only fluxes from standard measurements, but also from other measurements in terms of radiation. So we're going to work with GMD and PSD, and part of that's really trying to standardize ways that we do this so that we're comparing apples and apples, whether it's the Arctic or just in the contiguous United States. So that's all I have. How was that for being quick?
That was great. Thank you so much, Bruce. And last but not least, we have AOML. So Dennis,
Yeah,
I'm ready to take it away.
Hello again. So although our lab is mostly focused on lower latitudes, our current involvement in the Arctic research is limited. But first, what I want to mention and what is highly relevant for the Arctic research is that the AOML supports a global network of XBT transects, and among them, there are 2 high-density XBT lines in the subpolar North Atlantic. So one is AX1, shown on the left plot. This line is carried out on board the container ship New Arctica that regularly crosses the subpolar North Atlantic between Scotland and Greenland. And the other line is AX90, carried out on a ferry, Arona, that services the line between Denmark and Iceland. And these 2 lines are important because they cross the pathways of Atlantic water on its way to the Nordic seas and further into the Arctic Ocean. So these XBTs are deployed approximately 25 kilometers apart and about every 3 months. And both ships are also equipped with ship ADCPs that provide high resolution measurements of the upper ocean currents. So by combining ADCP and XBT measurements, we can compute the gross basin temperature transport, which provides a constraint for the analysis of heat budget at higher latitudes. And here, just I'm showing some references on recent volume of heat transport estimates that utilize the XBT data. Next slide, please. So, and now here, I want to present what we intend to do in the near future, expanding our research horizon towards the Arctic boundaries. And this is basically a proposal that we just submitted to NSF through the Cooperative Institute of the University of Miami. And this activity, if funded, of course, will be carried out in collaboration with the University of Rhode Island, Stony Brook University, and the Norwegian partners from the Institute for Marine Research, Berkner Center for Climate Research, Norwegian Institute for Water Research, and of course the ship operator. So as you know, the majority of oceanic heat is transported into the Arctic from the Atlantic Ocean across the Norwegian Sea, where the Atlantic water is carried by the Norwegian Atlantic current, and at the western entrance to the Barents Sea, shown in this map, which is also known as the Barents Sea opening, the eastern branch of the Norwegian Atlantic current bifurcates into the West Spitsbergen current that continues toward the Stram Strait, and the North Cape current that turns eastward and together with the Norwegian coastal current enters the Barents Sea between the Norwegian coast and Fair Island. So about what is interesting, that the amount of heat that goes into the Barents Sea based on observations and models is almost twice greater than the amount of heat that goes that is transported into the Arctic through the Stram Strait. So part of the Atlantic water transport through the Barents Sea open has been monitored by an array of current meters since 1997 by the Norwegians. However, even on a monthly time scale, the correlation between the measured and model transports through the Barents Sea opening is very poor. So in other words, it's an open question if the mooring array fully captures the inflow into the Barents Sea. And also the spacing between the moorings is about 55 kilometers, and there is a lot of activity on smaller scales. Also, the Norwegian coastal current south of the first mooring and outflow north of the Bear Islands, so basically the northern part of the Barents Sea opening, are not observed. So what we want to do, we propose to enhance the observing capabilities in the Arctic gateways by establishing a relatively low-cost multi-year high-resolution observing system to monitor volume and heat transports between the continental Norway and Svalbard on the timescales from seasonal to perennial. So we want to instrument, there is a cargo ship servicing the line between Tromsø and so between Tromsø and Svalbard. And so we want to instrument this cargo ship, Nordbjørn, with the ship ADCP and an automated XPT launch system. And so what they're going to do is that for each crossings, which there are 6 times a month, we want to obtain the full depth coast-to-coast velocity profiles, and once a month we will be launching XPTs to 3 temperature profiles. So using this information, we could calculate cross-section fluxes of volume and heat, and of course, again, we want to analyze the variability of these fluxes and investigate the mechanisms that drive this variability. So this is what I want to say.
All right, well, thank you so much, Dennis, for that update. And thank you to everybody on the line for calling in. I hope this was really helpful to see all of the many different activities that groups are doing across OAR in the Arctic. As a follow-up to this, I'm going to email out a list of those who were able to speak today with email contacts in case anyone wants to follow up. And I was also going to share the slides. Assuming that no one has an issue with me sharing the slides, I can reach out and make sure that it's okay that I distribute the slides. And Sandy or Jim, did you have anything you wanted to contribute?
I'll add that I think when we send out the distribution, we'll ask for some feedback on this format. We sort of weighed whether it would be more valuable to do this kind of format of quick high-level updates, or if people would like to be able to see maybe a few subset feature presentations moving forward based on some of the themes of common overlap. And so just reflect on what might be a useful ongoing format for this discussion, and feel free to give us some feedback.
And thanks everyone, and glad you called in, and we'll keep you informed on what OAR is thinking.
All right. Thanks, everybody.
Thanks.
Thank you very much.
Thanks for all the useful information.